Good morning to everyone. Today class is surface water pollution. So what is the difference between groundwater and surface water? So the water which seeps into the ground passes through the water table. So that is called groundwater. So any water that gathers on the surface of the earth, that is called surface water, right? Okay. So groundwater which seeps into the ground passes through the water table. So that is called groundwater. And surface water. So surface water, that water gathers on the surface of the earth surface, right? Earth. So that is called surface water, right? So surface water, that is water located on the top of the earth surface, such as rivers, creeks, and also wetlands. So this may also be referred to as blue water, right? So approximately 98%, right? 98% of the surface is covered by the surface water or salt water. And remaining 2% is fresh water. So this fresh water is ice plus snow water, right? So surface water, it can be replenished by precipitation and can pass through the atmosphere via evaporation, right? Evaporation. And so it is a crucial part of the planet's hydrological cycle, right? So you see here, so this some of the percentages of the this 98 plus 2%, right? Then next, surface water. Surface water can be studied under following these ways. So those are, first one is fresh water and second one is marine water. So surface water originates mostly from the rainfall, and it is a mixture of the surface runoff and groundwater. So fresh water, it is pollution of fresh aquatic systems, the surface following streams like rivers, like live streams, and also seasonal streams, and also surface water bodies like ponds, lakes, right? So marine water, pollution of oceans and saline lakes. So that is known as marine water pollution. So 80% of the marine pollution, it comes from the land only, right? Land. So it includes water pollution of subterranean water. So which is mostly used for the drinking and irrigation purposes. So this is properly known as the groundwater pollution, right? So I already told about the groundwater pollution. So the surface water body can be recharged with the rainfall or snow melting, right? So you see some pictures of here. So rivers and streams, and also wetlands, and also some of the rivers, streams also here, and lakes and ponds, right? So Next one is the impacts creating projects to the surface water environment. So in this environment, all surface water is never pure. Remember this, never pure. So pure water is always colorless, right? Pure water is always colorless. So about 70% of untreated industrial waste is dumped into the freshwater bodies in most developing countries, right? So thereby polluting the usable water supply, which is unsafe for the drinking and bathing and fishing and also swimming. So the natural or rainwater always contain at least some minimum amount of dissolved chemicals which originate from the atmosphere. So the development of water quantity and quality, it will be depending on the type and quality of receiving water. So not only on development type, right? So the various developmental activities which causes significant impacts on the surface water, which is normally required of detailed environmental impact assessment, right? EIA, right? So those projects, what are the projects you see here? So those projects are industrial power plants. So industrial power plants withdrawing surface water for cooling in power plants. So those are discharging heated wastewater from the cooling cycles, right? The next, industrial discharging process. So what is the industrial discharging process? So that is this process waste waters from either routine operation or as a result of accidents and spills, right? And discharging of municipal waste water treatment plants and also dredging projects in rivers or coastal areas and mining, surface mining projects. So with resultant changes in the surface water hydrology and also construction of dams. Construction of dams for purposes of water supply and food control and river channelization projects. So these projects for flow improvement, right? And also deforestation and agricultural development and also some of the irrigation projects. And next, commercial hazardous waste disposal sites and sanitary landfills and some of the tourism projects, right? So these projects are which causes significant impact on the surface water. Right? The next process of impact assessment on the surface water body. So what is the process of EIA of surface water? So we have 4 steps here. So first one is water quality and quantity. So environmental impacts of various human activities on the surface water environment with systematic processes. Those are proposed to water quality and quantity, right? So identification of surface water quantity and quality impacts of the various proposed project. And second one is preparation of description of existing surface water resource conditions. And also third one is procurement of surface water quality and quantity standards. And also next one is impact prediction of the surface water. And fifth one is assessment of impact significance of the surface water. And last one is identification and incorporation of mitigation measure. So this is the surface water environment process. Right? So wait, I will upload another PPT. So next one is water quality parameters. So what are the water quality parameters? So it is a activity to determine the futures of the proposed project, and water quality parameters, it can be broadly determined by the three types. Right? So first one is physical parameters, and then next one is chemical parameters and biological parameters. So these parameters are very, very important. So first one is physical parameters. You see here, physical parameters. So what are the physical parameters? Turbidity, taste and color, odor, taste and temperature, and also solids. So these are the physical parameters, right? So each parameter can be broken into subcategories also, right? So first one is turbidity. So it is the cloudiness, right? Cloudiness of water, or water is its clarity. So it is a measure of the ability of light to pass through the water, or how it clears the water. So it is caused by suspended materials such as uh, clay, silt, and also organic materials, and also plankton and other particulate matters in the water. So turbidity is measured by an instrument. So that is called what? Nephelometric turbidimeter, right? Nephelometric turbidimeter. So which expressed turbidity in terms of NTU, right? NTU. So NTU means nephelometer turbidity unit, right? Nephelometer turbidity unit. So drinking water should have turbidity less than 5 mg per liter, or 5 NTU, nephelometer turbidity unit. So this is the permissible limit. You see here, so this is the low turbidity to high turbidity. So you see the variation of this glass water, right? So this is very clear. And next one is, and last one is. So how it is the difference between this water? So this is the turbidity, right? So this is low turbidity, it is very clear, and high turbidity it is not clear, right? So turbidity is a measure of the light transforming properties of the water. So natural water, that is very clear, right? So that is low turbidity. Nature water is low turbidity. In high turbidity, water appears cloudy, right? So you see here. So high turbidity can create problems in the water. So this is the turbidity. So you see, so this is also IS Indian standards 10500. So in the year of 2012, so desirable limit 1 NTU, permissible limit 5 NTU. And risk are effects so interfere with disinfection and sources that is due to particulate matter, and treatment is activated carbon, air stripping, and oxidation and filtration. So this is the turbidity, right? So next one is taste and odor. So odor, we know pure water is always, what is that? Tasteless, right? Tasteless. So and also odorless, odorless. So pure water always tasteless and odorless. So therefore, if any type of taste and odor is present, it indicates water pollution, right? So taste and odor, these are measured by the instrument known as osmoscope. OSMOSCOPE, osmoscope, right? So intensity of taste and odor that is measured in threshold odor number, that is called TON. TON, threshold odor number. So taste and odor in water, it can be caused by the foreign matter such as organic materials, inorganic compounds, or dissolved gases. So these materials may come from the natural, domestic, and also agricultural sources, right? So Indian standards, so that is unobjectionable, and also risks and effects, so that is written X and mostly in chemical. Then sources, what are the sources of odor? Chlorine, hydrogen sulfide, organic matter, septic contamination, and methane gas. So septic contamination, methane gas, so these are very important. Right? And treatment. Treatment is activated carbon treatment and air stripping and oxidation and filtration treatment. Right? So this is the taste and odor. And the next one is color. So color means, so pure water is, I told, colorless, right? Pure water is always colorless. But a presence of suspended solids. So give apparent color to the water, which dissolved solids may import true color to the water. So material decayed from organic matter, that is namely vegetation and inorganic matter, is such a soil, stones, and rocks. So impact that is color to the water. So for example, iron oxide. So iron oxide gives reddish color, right? Reddish color. And manganese oxide, MnO, so that is gives a black or brown color. And also some humic acid, so that is gives yellowish brown color. So color is measured by the tintometer. TINTOMETER, tintometer, right? So the guidelines value maximum acceptable level. So for color of drinking water, so that is 15 TCU, true color unit, or HZ, true color unit, right? So risks or effects are visible tint and acceptance decreases, and sources are iron, copper, manganese, natural deposits, and also treatment is filtration, distillation, and reverse osmosis, and also ozonization. So this is the color. So HZ means Hazen units, or true color units, TCU, right? So next one is solids. So solids can be subdivided into two categories. So first one is suspended solids. And the next one is dissolved solids. So these two solids are the inorganic particles. That is, what is that? Clay and silt and fine sand. And organic particles, that is plant residues and bacteria and algae, etc. So these are present in the water. So for suspended solids, as per Environmental Protection Agency, that is called EPA. So the EPA, the maximum permissible limit is 300 mg per liter for the drinking purpose, drinking water, right? So physical parameters is over. The next we are going to chemical parameters. So chemical parameters are pH, hardness, chlorides, fluorides, nitrates and sulfates and also phosphates, some of the metals and DO, BOD, chemical oxygen demand and TOD. Or dissolved oxygen, biochemical oxygen demand and chemical oxygen demand and also total oxygen demand. So these are the chemical parameters. So metals, examples, what is that? Copper, something, iron and also aluminum, zinc, and also lead, etc., etc. So flame photometer. So flame photometer, a photoelectrical photometer. So that is a device used in organic chemical analysis to determine the concentration of certain metal ions, among them sodium, potassium, lithium, and also calcium. Right? So chemical parameters. So chemical pollutants present in the water either normally or introduced due to the humans and environmental activities like water resources and storage and also geographical regions and possible contamination sites also. So most of the chemical parameters, so when present at a concentration above the permissible limit, right? Above the permissible limits, it laid down by the water authorities like WHO, World Health Organization. It means World Health Organization and IS. So Indian standards and ICMR. ICMR. So Indian Council of Medical Research Standards, right? So these standards are we are using in this chemical parameters. So chemical parameters associated with the organic content of the water. So that is include pH, hardness, chlorides, etc., etc. Right? So first one is pH. So pH is a measure of the relative acidity or alkalinity of the water. So the pH scale ranges from the here. So 1 being the most acidic and 14. Last one is 14. So 14 being the most alkali. So 1 to 14. 1 is acidic, most acidic, and pH 14 is most alkaline. So solutions with a pH less than 7, right? Less than 7. So these are typically classified as acidic. So from here to here, right? This one. So these are acidic, and those greater than 7 as alkaline. So a pH of exactly 7, this 7 is that neutral, considered neutral. So normal rainfall has a pH of approximately how much normal rainfall? 5.6, slightly acidic. 5.6 means slightly acidic. It is going to atmospheric carbon dioxide gas, right? So this is the pH. So you see here desirable limit 6.5 to 8.5 and permissible limit is also 6.5 to 8.5. And risks are low pH, that is uh, corrosion, metallic taste, right? High pH, it indicates bitter or soda taste and deposit. And sources are neutral and treatment increased pH by soda ash, decreased pH with white vinegar or citric acid. So pH 7 is the neutral. Remember this. 7 is neutral. So less than pH 7 is up to 1 to 6 or less than 7 is, what is that? Acidic. And greater than 7 is alkaline, right? So this is the pH. And then next, hardness. Hardness, total hardness. pH means total hardness. So hardness is the concentration of multivalent metallic cations present in the water. So hardness, it may be included due to calcium and magnesium, aluminum and iron, etc. etc. So acceptable limit of the hardness of drinking water, it should be 200, right? 200 mg per liter. So hardness is determined by the EDTA method, right? EDTA means ethylene diamine tetraacetic acid, right? Ethylene diamine tetraacetic acid. So this is the table of the classification of the pH. So that is, you see here, 0 to 60. So that water is soft, right? And 61 to 120. So that is moderately hot water. And 121 to 180, it is hot water. And greater than 180. It means very, very hot water, right? So this is the total hardness. And then next, so nitrates. So nitrates, so high concentration of nitrate in the surface water, it can stimulate the rapid growth of the algae or plants, so which degrades the water quality. So nitrates are essential for the plant growth, but too much or too many nitrates are a bad thing. So too many nitrates can cause too much plant growth, which can reduce the amount of dissolve or DO, that means dissolved oxygens available in the water. So these nitrates are caused by the using fertilizers and animal and human wastes also. So what happened here with too many nitrates, right? So these nitrates come as runoff some fashion, or they can be runoff from the septic tanks leakings into the water supply. They could be runoff from the fertilizers that when we have sprayed on the croplands within the watershed, right? So permissible limit. So this is desirable limit 45 mg per liter and permissible limit 45 mg per liter. So some of the risks and effects, methe, methemoglobinemia or blue baby disease in infants, and also sources, livestock facilities, septic tanks, manure lagoons, and some of the household waste and fertilizers and natural deposits. So treatment are ion exchange, distillation, reverse osmosis. So this is called RO, right? You see here, so this data is from the DDWS. So in the year of 2011. So you see topmost 5 affected nitrate affected states. So highest is in the year of 2011, that is 18.85, right? And Rajasthan is 0.91 and Maharashtra is 0.77, Gujarat is 0.42, and lastly Kerala. Kerala is least, that is 0.38, right? So these are the 5 mostly affected states for nitrates. So chlorides. So chlorides, right? Chlorides occur naturally in the water, streams and lakes. So chlorides, it may enter into the surface water from several sources, including chloride containing rock and agricultural runoff and also wastewater. So chloride ions in drinking water do not cause any harmful effects on the human health. So, but high concentrations, it can cause an unpleasant salty taste, right? What is that? Unpleasant salty taste. So permissible limit, desirable limit is 250 mg per liter and permissible limit is 1000 mg per liter. So it causes high blood pressure and salty taste, and also some of the risk and sources, fertilizers, industrial waste, and seawater, and treatments also RO and distillation and activated carbon, right? So, so then next one is fluoride. So all of you know about this fluoride. So you see here. So So fluoride desirable limit is 1.0 mg per liter. So permissible limit 1.5 mg per liter. So excessive amount of fluoride, it can cause the discolored teeth problems, right? And also some of the bone problems also, bone damages, right? You see the dental fluorosis problems and skeletal fluorosis problems. So that is called above 1.5 mg per liter fluoride, right? So this is excessive amount, above 1.5, right? So you see here, so top 5 fluoride affected states. So those are Rajasthan, Karnataka, Bihar, Madhya Pradesh, and West Bengal. So in this top 5, highest is 8.51. Highest is 8.51. That is in Rajasthan, and West Bengal is lowest, that is 0.98. Right? So these are the some 5 fluoride most affected states in the year of 2011. So manganese also, so that is desirable limit is 0.1 and permissible limit is 0.3. So these effects are brownish color and black stains on laundry and fixtures at 2 mg per liter and bitter taste, right? And sources, landfills, deposits in the rocks and soils, and treatment is ion exchange and chlorination oxidation filter and green sand mechanical filter. So this is the manganese. So iron. So you see iron is also 0.3 mg per liter. So this is the desirable limit in the drinking water, and permissible limit, that is 0.3 also, right? So in case excessive limit of iron in the drinking water, so that is the effects on blackish color and rusty sediment and bitter or metallic taste and brown green stains, iron bacteria and discolored beverages. And sources are leaching of cast iron pipes in the water distribution systems in natural. So this is the treatment, oxidation, the iron. And next one is, so you see here top most 5 iron affected states. So that is Assam, Bihar, Chhattisgarh, Kerala, Orissa, right? So this is highest is 18.85. So lowest is 5.24, right? Arsenic. Arsenic also desirable limit is 0.01 and 0.05 is permissible limit. So it affects weight loss and depression, lack of energy, and skin and nervous problems. And sources, that is previously used in pesticides and also some of the improper waste disposals. And treatment is activated alumina filtration and RO and distillation and chemical precipitation, ion exchange and lime softening. So these are the treatments. So you see top 5 arsenic affected states. So highest is Assam, that is 2.4, and lowest is Karnataka, it is 0.07. And chromium is also desirable limit is 0.05 and permissible limit is also 0.05. So those effects are excessive chromium, that is skin irritation and skin, that means all of some skin problems, right? And damage to the nervous system. And also sources are septic systems, industrial discharge and mining sites, and also some of the geological sites. So treatments are ion exchange, RO, and distillation. So copper is also 0.05 and 1.5 is the permissible limit. So effects are anemia, digestive disturbances, and liver and kidney damage, and etc. etc. So sources, that is leaching from the copper water pipes and tubing. So, and also algae treatment and some of the natural deposits. Cyanide is also 0.05 mg per liter permissible limit. So these effects are thyroid, nervous system damage. So this is thyroid, right? So sources, fertilizers, electronics, steel, and plastic mining. So treatments are ion exchange, river osmosis, and chlorination. Lead also, permissible limit is 0.01. Right? So effects are, you see here, brain nerve damage and hearing problems and digestive issues and stone growth, right? So these are the effects. And sources is paint, diesel fuel combustion, pipes and solar and discarded batteries and paint, leaded gasoline and natural deposits, and RO and distillation and ion exchange activated carbons. These are some of the treatments. And mercury also permissible limit 0.001. Right? So these effects are loss of vision and hearing, and also some of the death at high levels, right? In sources, fungicides, batteries, fungicides, mining, and paper and some of the neutral deposits, right? In treatment, RO and distillation. Zinc also 15 mg per liter. This is permissible limit. So high zinc is metallic taste, right? So sources is leaching of galvanized pipes and fittings and paints, dyes, natural deposits. So treatment also ion exchange, water softness, and RO and distillation. Right? So some of the phosphates are also there. So phosphates also essential for the plant growth, but just like nitrates. So that is too many phosphates also bad things, right? The next DO. So DO means dissolved oxygen. Dissolved oxygen is nothing but it is presence of organic and inorganic waste in the water decreases to the dissolved oxygen content of the water. So water having DO content below the 8 mg per liter, it may be considered as contaminated, right? Considered as contaminated. So below 4 mg per liter. So this is considered to be highly polluted, highly polluted. So 8 is contaminated, below 8. So below 4 is considered the highly polluted. So we can enter in the water. So this DO is entered into the water in 3 ways. Those are through diffusion at the surface of the water. So through surface, which is just where you get oxygen molecules bouncing up the surface of the water. Some of them it will pass through the and dissolve straight into it, right? So the next one is through aeration. So aeration, which would be like the bubbler pumps. For example, you see inside aquariums, so in your homes, so like the fountain. So is there to oxygenate the water, right? So that is the aeration. So as a Third one is as a waste product of photosynthesis. So keep the decomposes alive. Aquatic plants also make water in. So if you have got plants grown under water, like in our eco columns, the duckweed growing in there, one help dissolve more oxygen in it, right? These are the dissolved oxygen. And BOD means biochemical oxygen demand. So BOD, so water pollution by organic wastes. So that is measured in terms of BOD, right? So it is the amount of DO, it is needed by bacteria in decomposing the organic wastes present in the water. So it is expressed in milligrams of oxygen per liter of water, right? So high value of BOD, it indicates low DO content of water. So that is pollution, right? So the optimum value is 1 to 3 mg per liter. So that higher BOD indicates pollution, right? The next COD. COD means chemical oxygen demand. So chemical oxygen demand is a slightly better mode for use to measure pollution that is load in the water. So it is the measure of oxygen equivalent of the requirement of oxidation of total oxidation, oxygen equivalent of the requirement of oxidation of total organic matter present in the water. So this permissible limit is 250 to 500 ppm. So COD measurement can be taken from few days. So the limit is 250 to 500 ppm. So BOD is the oxygen equivalent required for the oxidation of organic matter in the water, determined with the help of a storing chemical oxidant and usually potassium dichromate in acidic medium in the presence of the catalyst. Right? The next one is biological parameters. So what are the biological parameters? So these are the bacteria, pathogens, polytest or coliforms, and virus, and also protozoa. So these are the some of the biological parameters. So coliform means E. coli test for MPN. MPN means most probable number, right? So biological parameters, so it can be divided into two types. First one is biodegradable organic matter. And second one is non-biodegradable organic matter. So biodegradable organic matter, when in biodegradable organic matter, if organic substances is being decomposed by the action of microorganisms. So because they take the carbon as the source of the energy, then it termed as the biodegradable organic matter. So non-biodegradable organic matter. So it is similarly, if organic matter which can be not be decomposed, right? Not be decomposed, which where the utilization of carbon, it cannot be done by the microorganisms. So then it termed as the non-biodegradable organic matter. So most important organisms are pathogens, right? So because they are capable of transmitting diseases. For example, bacteria, virus, protozoa, helminths, etc., etc., right? So first one is bacteria. So bacteria, now we have classified into 4 types, right? So that is based on the shape of bacteria, right? So in that we have 4 types. First one is uh, spherical bacteria and rod-shaped bacteria, comma bacteria and spiral shape. So these are the shape of the bacteria. So you see spherical shape. What is the spherical shape? So that is also called coccibacteria, right? So spherical space means you see here some. So this is called spherical or coccibacteria. Rod-shaped bacteria, that is also called bacillus. So rod shape means you see here this something rod shape, right? So this is rod shape bacteria. And comma shape means all of you know comma, right? So this is comma shape. And also last one is spiral shape. Spiral shape means here you see this one like this. So this is the spiral shape. So this is also called spirilla, right? Spirilla bacteria. And this is also called comma shape, that is vibrio. And rod shape is also called bacillus. And spherical also called as coccibacteria. Bacteria. So based on the shapes, so bacteria is, so these are the 4 types, right? So based on the nature of bacteria. So this is shape, right? So this is nature. So nature, it is divided into 2 types. So, right? So that is harmless bacteria, that is called non-pathogenic. And harmful bacteria, that is called pathogenic uh, bacteria. So pathogenic means disease causing bacteria, right? Disease causing bacteria. So pathogens for testing and counting the pathogens, it is very difficult as well as it is very costly also. So next, coliforms. So this is also 2 types. First one is E. coli and second one is B. coli, right? E. coli and B. coli. So the organisms whose presence in the water indicates so that the water has been contaminated, right? Water has been contaminated. So for example, E. coliforms, that is E. coli, B. coli. So these are the harmless aerobic microorganisms. So which are found in the intestine of all warm-blooded animals and also their excreta. So they are harmless microorganisms. So but their presence indicates the presence of the pathogens, right? So organisms whose presence in the water indicates that water has been contaminated. So that is called pathogens, right? So harmless aerobic lactose fermentous organisms So flora and fauna are also affected by the various developmental projects. So this is the water quality parameters, right? So now class is over. So next class, Vasanti madam will taking, right? So only 1, 2, 3, 4. Only 4 members is present here today.
Ma'am?